Vitamin E is a powerful fat-soluble antioxidant that plays a crucial role in protecting the body's cells from oxidative stress, one of the main factors involved in the development of neurodegenerative diseases, such as Alzheimer's and dementia. Oxidative stress is a process in which free radicals damage healthy cells, including those in the brain, accelerating cellular aging and promoting neuronal degeneration. Vitamin E works by neutralizing these free radicals, helping preserve the integrity of brain cells and cognitive function over time. Scientific studies have shown that vitamin E supplementation can reduce the risk of neurodegenerative diseases by increasing the resistance of nerve cells to oxidative stress. This is especially important because the brain is one of the organs most vulnerable to the damage caused by free radicals due to its high oxygen consumption and the presence of large amounts of polyunsaturated fatty acids, which are highly susceptible to oxidation. Vitamin E, when incorporated into cell membranes, acts as a protective barrier, preventing free radicals from damaging essential cellular components such as lipids, proteins, and DNA. In addition, vitamin E also has an anti-inflammatory effect, another important factor in preventing neurodegenerative diseases. Chronic low-grade inflammation that occurs in the brain with aging can contribute to neuronal loss and the progression of diseases such as Alzheimer's. Vitamin E modulates the inflammatory response by helping reduce the release of pro-inflammatory cytokines, substances that exacerbate brain inflammation and promote the development of neurodegenerative disorders. As a result, it can slow down or even prevent the degeneration of brain cells associated with conditions such as Alzheimer's disease. The protective effect of vitamin E on the brain is also related to its ability to regulate lipid metabolism. Vitamin E helps maintain the balance of essential fats in brain cells, promoting membrane fluidity and communication between neurons. This process is crucial for cognitive function, as it allows electrical signals to be transmitted efficiently between neurons, facilitating memory and learning. Another important point is the impact of vitamin E on the formation of amyloid plaques, a characteristic feature of Alzheimer's. Amyloid plaques are formed by aggregates of beta-amyloid proteins that accumulate in the brain, causing damage to nerve cells. Studies suggest that vitamin E may help prevent or reduce the formation of these plaques, protecting neurons from the accumulation of proteins that contribute to the progression of Alzheimer's disease. Although the exact mechanisms are still being investigated, scientific evidence suggests that vitamin E has properties that may slow the accumulation of beta-amyloid, thereby protecting brain function. Vitamin E supplementation has also shown benefits in terms of preventing age-related cognitive decline. As we age, brain function tends to decline, and conditions such as memory loss and difficulties concentrating have become more common. Vitamin E has been associated with improved cognitive function in the elderly, with several clinical studies indicating that regular intake can help preserve memory and other brain functions as we age. This effect may be particularly important for populations with a high risk of developing neurodegenerative diseases, such as those with a family history of Alzheimer's or who have risk factors like hypertension or diabetes. In addition, vitamin E is often used in combination with other essential nutrients for the brain, such as omega-3 fatty acids, which are found primarily in fish and nuts. The combination of vitamin E with these fatty acids can increase protection against oxidative stress and improve brain function. Studies have shown that this combination can enhance antioxidant and anti-inflammatory effects, offering a more effective approach to preventing neurodegenerative diseases and supporting cognitive health. In a study published in the Journal of Alzheimer's Disease, significant improvements in cognitive function were observed in individuals who took vitamin E supplements compared to those who did not. Participants who received vitamin E showed a slower rate of cognitive decline, suggesting that vitamin E may be effective in protecting against early brain aging and maintaining mental health. Although more research is needed, these findings indicate that vitamin E could play an important role in the strategy for preventing neurodegenerative diseases. It is also important to emphasize that vitamin E plays a crucial role in the overall health of the nervous system. It is involved in protecting nerve cells from the toxicity of heavy metals, such as mercury, which can be harmful to the brain and nervous system. Furthermore, vitamin E can help improve cerebral blood circulation, which facilitates the supply of oxygen and essential nutrients to the brain. This results in more efficient brain functions, and an increased ability to respond to external stimuli. Another significant benefit of vitamin E is its ability to improve sleep quality. Good quality sleep is essential for brain health, as it is during sleep that the brain carries out many of its recovery and regeneration processes. Vitamin E deficiency has been linked to sleep disorders such as insomnia, which can contribute to an increased risk of neurodegenerative diseases. Vitamin E supplementation has been shown to help regulate sleep cycles, promoting deeper and more restorative sleep, which is beneficial for long-term brain health. Studies also suggest that vitamin E can have a positive impact on mood and emotional well-being. Vitamin E acts on the central nervous system, regulating neurotransmitters essential for mood control, such as serotonin. Vitamin E deficiency has been associated with symptoms of depression and anxiety, which can exacerbate the risk of neurodegenerative diseases. Supplementing with vitamin E can help improve emotional states and reduce symptoms of stress, creating a healthy environment for the brain. Vitamin E also has been shown to be effective in preventing cerebrovascular diseases, which can affect blood circulation in the brain and lead to cognitive and memory problems. By improving vascular function and protecting blood vessels from oxidative damage, vitamin E can help ensure that the brain receives an adequate supply of oxygen and nutrients, preventing brain damage related to poor circulation. This is particularly relevant for elderly individuals or those with a history of cardiovascular diseases who are at a higher risk of stroke or other cerebrovascular complications. In addition to its antioxidant and anti-inflammatory effects, vitamin E may act on the modulation of the endocannabinoid system, a complex biochemical signaling system that affects various bodily functions, including pain regulation, mood, and cognitive function. Studies indicate that vitamin E may positively influence this system, helping to reduce symptoms of neurodegenerative diseases such as Alzheimer's and providing additional protection for nerve cells. Regarding Alzheimer's prevention, vitamin E has been shown to be most effective when combined with other antioxidant nutrients, such as vitamin C. Vitamin C, in turn, helps regenerate vitamin E in its active state, enhancing its antioxidant effects. This combination of nutrients has proven effective in protecting against oxidative stress in the brain and preserving cognitive functions, helping prevent the early onset of neurodegenerative diseases. Finally, vitamin E is widely accessible and safe when used as a supplement. Clinical studies demonstrate that adequate doses of vitamin E do not present significant side effects, making it a viable option for most people seeking to support brain health and prevent neurodegenerative diseases. However, it is important to follow dosage guidelines to ensure that the benefits are maximized without health risks.